Today we are going to conduct an experiment called as a profile projector. What is this profile projector? Profile is projecting. So whenever you want to measure any tools or any very important dimensions in a inspection, you can use this profile projector. It works just like in your TMM only, tool makers microscope only. Here we are doing in a tool makers microscope, we are going to do with a manual. Here everything is automatic. So what are the things here? I will explain you now. Here we have a screen. So you can see this, how the screen will look like. It will be look like this. Here we have a crosshair. Crosshair is nothing but your reference line. Crosshair is nothing but reference line. So here we have a measuring system, strain measuring directly. Like LVDT, we have a strain measuring system like 1 micron system, very accurate thing. And this line is very accurate for us. And we have a bevel protractor here, like your 0 to 180 and 0 to 180, red scale and black scale. Both are common. You can see this. Here, I am just explaining you the same thing, the thread profile, how to measure the thread profile using a profile projector. In a tool maker's microscope, we will do a manual. Here, you can directly do through the automatic systems. Here we have a microstrain measuring systems. You can see this. The microstrain measuring systems will directly show you 0. If you move a line, I am just moving a line on here. So you can see this. If you press reset, it will go to the 0, and you can see this. It's showing 0.000. It means what is the least count of your linear means 0.001. That is 1 micron here. That is what you can directly take the reading on here. I am just moving a reading here. You can see this, how accurately it's moving. You can read, you can move out single digit also. So that is your linear scale. So if you want to measure the major dia, so what we will do, we are going to take the major dia here. From this to this is major dia. From this to this is minor dia. From one distance between the two consecutive threads is your pitch. Any of distance you can take directly here. So how to do that? I already explained the light principle. It will directly come from the base. It's projected in your camera and it is projected in your screen. Shadow principle here. So if you want to measure the surface, it is very easy. You can see this. It's showing you the surfaces on here. So if you want more clarity, here we have a system called as an up and down movement. If you do this, you can see this. There is a blurriness came here. If you want more clarity, you can see there is no shadow on your system. This is what happening. So this is more clarity now. Now I want to measure the major dia. Which direction you are moving? This is your x-axis. This is your y-axis. So if you are moving a y-axis, the y-axis reading has to be noted down. If you want to measure a pitch, you are moving in an x-axis. The x-axis reading has to be taken down. How to do this? See, I just mentioned a crosshair has been perfectly butted to a top line. I am just going to press a reset button in a y direction. If you move the y direction, you can see this. If you move gradually the y direction, you will directly get the reading on here. You can directly see this. It is 23.978. M24 I am measuring here. It's giving some 23.978. Directly the reading has been given on here. Okay. So like that, major dia, minor dia. To measure the pitch, very simple thing to measure the pitch. How to do that? So I am going to take distance between the two consecutive threads. Either I can take like this. This is my first consecutive thread. So I am measuring in a, or you can take any one reference point also that belongs to you. So I am just making a x as 0. I am just moving another one thing on here. Distance between the two consecutive threads will give you the pitch here. You can directly take the pitch 3.013. That is the reading. It has been directly given to you. This is how to conduct the major dia, minor dia and pitch of the system. And one more important is there, that is angle of the thread. How to find the angle of the thread. This is very important. I am going to explain you. So here we have a black scale. Here we have a red scale. We are doing a manual bevel protractor to read this. How to do this? Here 0 to 10, how many divisions are there? 0 to 10 degree. Count this from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 plus 10 is 20 divisions. Your 0 to 10 degree is divided by 20 divisions here. So you can see this 0 to this is 0, 0 to 10 you have a 20 divisions. So what is the least count of your MSD? MSD is 0 to 20. 0 to 10 degree we have 20 divisions. 0.5 degree. It's not 0.5 degree. Actually it is 30 minutes. It means 1 degree is equal to 60 minutes. That is divided by 2 here. That is 30 minutes is the least count of your MSD. And that 30 minutes is divided in a vernier scale. You can see this. You have two types. I will explain. I explained in the tool makers microscope also. So we have a black scale and a red scale. 0 to 30. They have been made 30 divisions here. So what is the least possible measurements you can do using a bevel protractor here is 1 minute. In tool makers microscope it is 6 minutes. Here it is 1 minute. So each division is giving a 1 minute here. Black scale. See, you can see this. This is black scale. If you are reading a black scale, you should always read the black scale here. If you are reading the red scale, you should always read the red scale on here. How to take the reading? You can see this. There is a lock. You can open this lock. So you can see this. I'm just don't touch in the center of your screen. See this. I'm just making a parallel to the system. I just make one parallel to the system. See this, how much it has been crossed, you can count it from here. It's crossed 20, 25 degree, it's crossed 26, 27, 28 degree crossed. 28 degree, 30 minutes crossed, not reach the 29 degree. So MSD is 28 degree, 30 minutes, and you can see which line is coinciding. The line is coinciding is here is the 5th division. So 28 degree, 35 minutes is the reading. Like that. 1 degree, 1 has been taken. I'm just coming back to the original position, 0. And same, I'm here only. So I'm going to take the alternate one, this angle. Now you can see I'm taking in a red scale. Now I took in a black scale. Now I'm taking in a red scale. You should start reading from here 0 to 10 degree, 20 degree, 30 degree, 30 minutes cross, not reach the 31 degree. And you have to read in a red vernier scale. If you add the both, you will get the reading. This is one method. Sir, I don't want to read in a black and a red scale. Suppose if a student asks, you can make another one thing. Instead of this 0 degree, I am going to make it, I am just keeping in a middle, I am make it this as a 0 here. What is that? 90 degree as a 0 on here. 90 degree as a 0 on here. I can make it like this. So now this is a 0. Now you can take one reading on here. One reading on here. It's come around 120 degree. And I'm coming back to the original position 90 degree. I'm just taking the another one same reading on here. You can see this, it's coming around 60 degree. So 120 minus 60 will give you the 60 degree, or 30 plus 30, it will also give you the 60 degree only. It means if you read both the reading in a black scale, you need to subtract, or both the reading in a red scale, you need to subtract. If you take one reading from the black scale and one reading from the red scale, you should add. But you should know the least count of your system. If you are reading the black scale, you should read the black. If you are reading a red scale, you should read the red vernier. Thank you.